Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yakoob. So now we are starting the online batch, and today is the first lecture, lecture 01, and this lecture is about pure math P3, and it's about P3, it's about S2, it's about M1. We won't talk much about S2 and P1 in this class. uh, we will be focusing on P3. That is the first thing. Okay. So now, when we talk about this thing, P3, S2, M1, so first of all, let's highlight each thing. That is P3, and then S2, and then M1. So either someone takes P3 and S2, or someone takes P3 and M1. P3 is paper 3. S2 is paper 6. M1 is paper 4. Now, the very first thing people ask is that who can take P3S2? So, P3S2, anyone can take it. Okay. So, anyone can take P3 and S2, no issue. What about P3 and M1? So, P3 and M1, it can be taken by only science students who are passionate about physics. Otherwise, it creates a lot of trouble. And is S2 easy or M1 easy? Personally, I have no issues. But as far as student perspective is concerned, people find S2 to be easier. That is for later on. Let's talk about pure math P3 for today. And we will study a bit also. We will also discuss the syllabus. Pure maths P3, this is 1 hour, 50-minute paper. That is the time duration. That is 110 minutes. The most important, most precious 110 minutes of your life. You will be giving this exam next year, inshallah. They ask 10, actually, they usually ask 11 questions, 11 to 12 questions. There is no choice, just like P1. And you have to work in the answer space. Knowledge of P1 is assumed. That is the first thing that I want to show you. So look over here. This is from the syllabus. So the very first thing that they're saying is that whatever you have studied in P1, that is assumed. So let's read this thing. Knowledge of the content of P1, knowledge of the content of paper 1, pure math 1 is assumed, and candidates may be required to demonstrate such knowledge in answering questions. Now, let me first write down what are the topics of pure math P1, what are the topics of pure math P3, and let's compare the two. So, pure maths P3 versus pure maths P1. So, let me choose this color. That's right over here. So, how many topics were there in pure maths P1? There was coordinate geometry, circular measure, trigonometry, series, AP, GP, binomial. And let me write over here AP, GP, binomial. Then there is quadratics. There is functions. Then there is differentiation. And then there is integration. That's a symbol for integration that I write. When we talk about P3, first thing is algebra. Second thing is logs and indices or indices, whichever way you want to pronounce it. The third one is trigonometry. The fourth one is differentiation. The fifth one is integration. And the sixth one is differential equations. Differential equations. Then there is numerical solution of equations. Then there is vectors, and then there is complex numbers. Now, if I focus on these things, uh, circular measure, yes, that is carried forward. It's used in this chapter, that is numerical solution of equations. Binomial is carried forward. It's used in algebra. Quadratics, it's carried forward a lot. It can be used in differentiation. It can be used in what you call complex numbers. It can be used in trigonometry. It can be used in algebra. So quadratics is everywhere. Coordinate geometry. Coordinate geometry can be used in integration, can be used in differentiation. What else? What about trigonometry? Yes, that's used a lot right away. Differentiation, that is used a lot. Look at the connection. Integration, that is used a lot. And then vectors from O level maths, complex number, that is like basic maths. So basic of maths is required. So technically, every single chapter is linked. Now have a good look. Take a picture if you want to, a screenshot if you want to. So that is the connection between pure maths 1 and pure maths 3. So some people, they ask me this question, sir, can we give composite 4 papers? If they have already given AS level, yes, you can, because a lot of things are linked. So now let's carry it forward and let's talk about the difficulty level. So when we talk about the difficulty level, so understand it like this. Let me put a strip over here, a small strip like this, and let me put another strip over here like this. Now, if I talk about trigonometry, if I talk about differentiation, if I talk about integration, these three topics carry forward. So if this is like 100%, then around approximately 20% you have studied in P1, the rest of the 80% you would study in P3. So if you take every topic, more or less, this is the ratio, a very conservative estimate. So 20% is studied in P1, 80% in P3. That's what makes the A-level syllabus. So that's the complete A-level syllabus. And these three topics, they carry forward. So now look at your WhatsApp and just acknowledge if everything is making sense till now. Just put a tick mark, just put yes, something like that. I'll be forming a group soon. Okay. Any question? I'll be okay, Ji. Now, some people could say that they are studying S1 and A2 and M1 and AS level. I think this happens in, I think, 2 places. Either it happens in our province of Punjab. I'm not sure about KPK or Balochistan, but it happens in Punjab, or it happens in UAE or Saudi. So these two are the places that's where it happens. So don't worry. Those people who are studying M1, I'll be teaching them M1 for A2 people also, and the other people could be studying S1, so that's not an issue. Now, what we can do is that let me start with the very first topic. And that very first topic is about algebra. And I think it would fit in this thing. So that is the screenshot that I want to take. So now let's paste it over here. The very first topic, yes, I need to list down the topics which I did. And we get started with the very first topic. This 3 stands for P3, paper 3. And this one over here, this stands for topic 1. So it's the first topic of P3, 3.1. Now there are 4 things in it. What are those 4 things? Let's have a look. This thing is about modulus. These 2 things, let me just highlight it first. Now, first thing first, the thing at the very bottom, this is about binomial expansion. So we will start with this today, binomial expansion. In the first topic of algebra. So we are starting with this. The second one, this is called partial fractions. So that is the second topic. The third topic, this is polynomials. And the fourth topic, that is about modulus function. Let's call it modulus function because it has equations, it has graph, inequalities, and everything. So there are 4 subtopics of algebra. Let's start with algebra. We are starting with algebra. Let's start with binomial expansion. So now over here, we have this thing that is the P1 versus P3 binomial expansion. What is the difference between the two? Because you have studied it in P1 also. So now in P1, you were dealing with 2 expansion. The first one was 1 plus b raised to power of n. And the other one was a plus b raised to power of n. That was the expansion that you dealt with. You dealt with the idea that n is a positive integer. The power was a positive integer. The number of terms, the hashtag is for number of terms, is always 1 more than the power. If there is a positive sign, all terms are positive. If there is a negative sign, sign alternates. What else is there? We can have this thing, which is we use the button of NCR, and we have this idea NC0 is 1, NC1 is n over 1 factorial, and NC2 is n minus 1 over 2 factorial. I have written in the expanded form. NC3, that is n minus 1, n minus 2 over 3 factorial. That's 3 into 2 into 1. So I think more or less this is what we have done. Now when we talk about P3, we only deal with one expansion, which is 1 plus b raised to power of n. The first term has to be 1. The first term has to be 1. If it's not 1, we will take common. N is a positive integer. n could be a negative integer, n could be a positive or a negative fraction. Both are possible. Number of terms is 1 plus n. That means it's a finite series. It has a finite number of terms. Now over here, since the number of terms is the n can be a negative integer or a positive negative fraction, therefore it's an infinite series. So the examiner will tell you where to stop. Over here, compared to this, there is no such rule. The first term could be positive, second could be negative, sign could be alternating, two terms are positive, the rest are negative. There is no such rule. Now you cannot use NCR. You have to use the NCR button from calculator cannot be used. So this NCR from calculator can be used. Now you are only left with the conceptual way of evaluating NCR by using this. NC0 is 1, NC1 is n over 1 factorial, NC2 is n minus 1 over 2 factorial, and so on. So we have to use this thing. That is the difference between the two. Now, the formula, that is 1 plus b raised to power of n, that is NC0, b raised to power of 0, NC1, b raised to power of 1, NC2, b raised to power of 2, NC3, b raised to power of 3. This is for P1. All the way till NCN b raised to power of n. This is for pure maths P1. In other words, n is a positive integer. The power is a positive integer. Now, when I write for this thing, which is 1 plus b raised to power of n. So now this would be NC0, b raised to power of 0, but we cannot use NC0. So we have to write it down. So this is 1, b raised to power of 1 over 1 factorial. And over here, this is NC0, NC1, that is n minus 1 over this thing. The first one is just this thing. Hold for a second. There is no need of writing 0 factorial or 1 factorial like this. So first one, simply write it as 1. The first one is 1. The second one over here, that is n, and this thing is b raised to power of 1 over 1 factorial. This is n minus 1, b raised to power of 2 over 2 factorial. This is n minus 1, n minus 2 over b raised to power of 3 over 3 factorial. It can also be written as, let me push it to the corner. And let me push this thing closer. So now this is n minus 1, n minus 2, n minus 3, b raised to power of 4 over 4 factorial. Just double check the terms and it's an infinite series. The first one will be 1. The second one would be n b power 1 over 1 factorial. n minus 1 b power 2 over 2 factorial. n minus 1 n minus 2 b power 3 over 3 factorial. n minus 1 n minus 2 n minus 3 b power 4 over 4 factorial. That's the maximum number of terms you need. Focus on this. Power 1 over 1 factorial. Power 2 over 2 factorial. Power 3 over 3 factorial. Power 4 over 4 factorial. And there are one term, the power is 1, one term associated with n, two terms associated with n, three terms associated with n, four terms associated with n. They are reducing one by one. The very first term is unique. Just simply write a 1. no need to think more about this. So now, is this formula all good, all clear? Just acknowledge this. This thing over here, I mean, it won't be possible for me to reply to every single one of you. Yes, when I'll form a group, then I'll be able to write in that group. So right now, I hope this is all good, all clear. Of course, I'll be doing examples of these. Okay, G. So this thing is done. Now, what I'll do is that let me take some examples and let me do the working. So now worked example one. In all these worked examples, I'm writing this thing, find in ascending powers of x the first four terms in the expansion of, when it says expansion, that means binomial expansion, in the expansion of dot dot dot. And that is where I'll be putting in different things over here. So now over here, this is 1 over 1 plus x. That's the first one. I have to take it upstairs. 1 plus x raised to power of negative 1. This first term has to be 1. Power comes, power is over here. X remains as it is. Power is 1 divided by 1 factorial. Then negative 1, negative 2, x raised to power of 2 over 2 factorial. Then negative 1, then negative 2, then negative 3, x raised to power of 3 over 3 factorial, and so on. Now over here, we have this thing. This is negative. There are two negatives over here. There are three negatives over here. So therefore, this term will be negative. This will become positive. This will remain as negative. That's the first thing that you need to take care of. The second thing that you need to take care of is the cancellation. 1 factorial and 1. This is also 2 factorial at the top. This is also 3 factorial at the top and at the bottom. So technically, everything is cancelling out. So this is 1 minus x plus x square minus x cube. That is the first four terms of this expansion. 1 over 1 plus x is 1 plus x raised to power of negative 1. Let me do 2-3 examples, and then I'll give you time to copy it down. Let me go to the next one. Again, the first four terms. Worked example 2. Let me write 1 over 1 plus x the raised to power of 2. That is 1 plus x raised to power of negative 2. That is 1 plus negative 2 x power 1 over 1 factorial. Negative 2, negative 3 x raised to power of 2 over 2 factorial. Negative 2, negative 3, negative 4 x raised to power of 3 over 3 factorial, and so on. Again, take care of the positive negative sign. This is negative. This becomes positive. This is negative. Let me write it down. Negative, positive, negative. Now let's focus on the cancellation. This 2 will remain. This 2 factorial and 2 will cancel out. This 3 factorial is 3 into 2 into 1. This will cancel out. Okay. So now I'm left with 1 minus 2x. And this is positive 3x squared. This is negative 4x cubed. And so on. That is the first four terms in the expansion of this. Now let me join question 2 and 3. Worked example 3. Find the first four terms in the binomial expansion of 1 over 1 plus x, 1 over 1 plus x plus 1 over 1 plus x whole square. So this is 1 plus x raised to power of negative 1. This is 1 plus x raised to power of negative 2. The answer of the first one is 1 minus x plus x square minus x cube. 1 minus x plus x square minus x cube. This is worked example 1. And this one right over here, 1 minus 2x, 1 minus 2x plus 3x squared minus 4x cubed. So this one is worked example 1. This one is worked example 2. And I'm simply adding it up. So now if I add it, this one will be added to this one, which is 2. Negative x, negative 2x, that is negative 3x. Positive x squared, positive 3x squared, that is 4x squared. Negative x cube, negative 4x cube, that is negative 5x cube. That is the first 4 terms in this expansion. All good, all clear? So now let me pause the recording. For 7 minutes, 8 minutes, I want you to copy it out. Take your time, actually 10 minutes, no worries. So now people, let's continue. And that was worked example 3. Let me write down worked example 4. So worked example 4 this time, it is 1 over, actually let me write it like this. 1 plus x square root, again the first 4 terms. That is 1 plus x raised to power of half. That is 1. This is half. This is x power 1 over 1 factorial. And this is half. Half minus 1, that is negative half. X raised to power of 2 over 2 factorial. Let me write it as like this. And also let me write it more neatly. And this one, another term, that is half. Half minus 1 is negative half. Half minus 2 is negative 3 over 2 x raised to power of 3 over 3 factorial. Now look at the working that I'm doing. Division by 2 factorial is multiplication by 1 over 2 factorial. Division by 3 factorial is multiplication by 1 over 3 factorial to make life simpler for us. Again, take care of the positive, negative. This is positive. This is positive. This is positive. This is negative. This is positive, negative, negative. So now it goes like this. This is positive. This is negative. This is positive. That's the first thing. And let's play around with the numbers. So therefore, this is 1. This is half x. This is 2 over here, 2 over here, 2 over here. How much is that? 8. So that is x square over 8. There is 2, 2, 2, and 6. So 8 6 are 48. And there is a 3 at the top. So that is positive 3 over 48 x cubed. And of course, I can reduce it down. I'll do it in a short while. Let me write it like 1 over 8 x squared. Let me simplify it. That is 1 plus half x minus 1 over 8 x squared plus 1 over 16 x cubed. These are the first 4 terms. So worked example 4, all good, all clear. Let me do worked example 5. Worked example 5. Let me write, what if the first term is not 1? So this is 8 plus 4x. And this time it is cube root. So that is 8 plus 4x raised to power of 1/3. That is 8 common. 1 plus 4 over 8x raised to power of 1/3. Now, let me ask you to think. Pause and think. Is this step all good, all clear? Nope, it's not good. The reason is this power over here of one third, that is applicable on everything. So that is applicable on everything like this. Got it? So hold for a second. So this one is applicable on this whole thing. So I need a bracket over here. I need a bracket over here. And this one third over here, that is like this. That is applicable on the whole thing. Now it makes sense. So now this one third, it's applicable on the 8, it's applicable on the bracket. So now write it down. This is 8 raised to power of one third. This is 1 plus half x. Yes, you can reduce it, raised to power of one third. 8 raised to power of one third is 2. This is 1 plus half x raised to power of one third. Now I can simplify on the inside. That is 1 plus one third into half x power 1 over 1 factorial. Even if you want to skip it, you can. And this is one third half x, one third minus 1. Hold for a second. I missed out a term. This is one third and one third minus 1, negative two third. This is half x power 2 division by 2 factorial, 1 over 2 factorial. And let me just close the bracket over here. So I need more space to close the bracket. So this time I'm just getting the first three terms. Now focus on this. That is, this is positive, this is positive, this is positive, this is negative, this is positive. So therefore, this one is this one is positive, this one is negative. Let's play around more. This is 2. This is 1 plus 1 over 6x. And what is this? This is one third and two third, and this 2 over here. So 3 and 3 is 9. This 2 and that 2 will cancel out. This 2 and this 2 will cancel out. So that is 1 over 9. And this is 1/4 x square. Got it? And yes, there is a negative sign. So let's not forget this. So now let me simplify. Open up with a 2. That is 2 plus one third x. And 9 into 2 is 18 minus 1 over 18 x square. These are the first three terms in this expansion. So now just acknowledge, is this worked example 5 all good, all clear? I'll check on the WhatsApp. Worked example 5. Okay, got it. Okay, Ji. So now this is all good, all clear. So now let me do one thing. That is, I can also do some multiplication together. For example, let me write it like this. Worked example 6. That is, find the first three terms in the binomial expansion of 1 plus x over 1. Let me write over here. Hold for a second. 1 plus 2x over 1 plus x. The first three terms or the first four terms. Okay. So now over here, this is basically 1 plus 2x and 1 plus x raised to power of negative 1. Now, this thing 1 plus x raised to power of negative 1, that is worked example 1, I think. 1 plus x raised to power of negative 1 is this thing. 1 plus x raised to power of negative 1, 1 minus x plus x square minus x cube. So this is 1 minus x plus x square minus x cube. And let me just double check over here. Yes, positive, negative, positive, negative. Okay. This is the first four terms of this thing. So that's right over here. That is this thing, 1 plus x raised to power of negative 1. That is these four terms. And let me jot down these two terms as it is. The power is 1, so there is nothing special in it. So this is 1 plus 2x. Now let's multiply it out. So this 1 will multiply with everyone. So 1 minus x plus x squared minus x cube. Let me take this 2x and multiply with everyone. 2x into 1 is 2x. 2x into negative x is negative 2x squared. And then positive 2x cube minus 2x power 4. And let me change the question a bit. Let me write, find the first four terms in the expansion of this. So now I can add it vertically, which is a very intelligent thing to do. That is adding vertically. So let me just add it vertically like this. It's easier. So that is 1 plus x minus x squared. And this is plus x cube minus 2x4. But since they are only asking for the first four terms, so the final answer is 1 plus x minus x squared plus x cube. These are the first four terms in this expansion. So all good, all clear. That's how this thing is done and dusted. That completes the concept of binomial. So lecture number 1, we talked about syllabus. We understood binomial expansion in totality. Yes, there will be questions related with partial fractions that we will do later on, but technically, theoretically, we are all done and dusted. That is how we will uh, do every single chapter in this manner. Take care, everyone.